Hello, my name is Rick Sanchez, and the title of my brief talk is Innovative Ultraviolet and Ozone-Resistant Materials for Hydraulic Clamp Cushions. I'm from LynnTech Inc., located in College Station, Texas, and the Navy has asked our company to find an alternative material for hydraulic single-loop clamp cushions that is capable of meeting their specified requirements. In the next few slides, I'll be providing a brief introduction of our company, the opportunity given to us by the Navy, and how LynnTech has been able to provide a technology that will reduce the overall costs associated with the frequent failure and replacement of the hydraulic clamp cushion currently utilized by the Navy. On the next slide, I'll provide a brief overview of our company. On this slide is just a brief overview of the company. LynnTech is a versatile small business company that was founded in 1987, and we have over 30 years experience in developing and transitioning innovative technologies and systems based on electrochemistry alone. As such, LynnTech has a well-diverse group of disciplines that allow for research and development in areas of materials, devices, and system-level technologies. LynnTech has also a proven record of matching technologies with the corresponding appropriate business models towards successful commercialization. In recognition of this, LynnTech has received the 2016 Tabis Award that recognizes organizations that have made a visible technological impact on the socioeconomic front and exemplify the very best in SBIR achievements. On the next slide, we'll be discussing the opportunity the Navy has given LynnTech. On this slide, we're going to go ahead and talk about the opportunity the Navy has given LynnTech to work on the current issue at hand. So the Navy has launched a comprehensive program to extend the service life of its fleet of aircraft with the goal of having aircraft fly longer than originally intended without major maintenance due to hydraulic clamp failure. Hence, the Navy has asked LynnTech to develop an alternative material for their single-loop clamp cushion that is resistant to ultraviolet light and ozone while also being compatible with the relevant fuels and fluids used by their fleet. The current 85052B legacy clamps use a nitrile butyl rubber cushion that is used to reduce loading and vibrational effects, but here lies the problem. Soon after the clamps have been installed, sporadic cracking and discoloration occurs, dictating clamp failure and triggering clamp replacement. These types of failures is a common maintenance issue, and if not replaced in a timely manner, can lead to unwanted friction, pipe failure, or damage to aircraft components, causing an increase in the overall cost and reducing fleet readiness. As such, failure stems from the degradation of nitrile butyl rubber caused by UV and ozone exposure. Now, in order to meet the needs of our customer, we had to provide a material that is resistant to UV, ozone, while also being compatible with relevant fluids and fuels used by their fleet. As such, after identifying and preparing the clamp cushion material, the next step is to validate and certify the material, ensuring it meets the Navy's mil-spec requirements specified in the MIL C 85052A sheet. Overall, the goal that LynnTech's alternative clamp cushion material is to provide fewer maintenance cycles, lower costs, and increase in fleet readiness and support to current and future operations. To meet the needs of the Navy, our technology solution is basically to utilize materials that already locked in certain criteria that met the Navy standards, and this is further discussed in slide 5. So if you look at the top left corner of the slide, we have a picture of the legacy clamp 85052B, and with it the common issues observed by the maintenance crew. Now, LynnTech's solution to the problem the Navy currently has is the use of materials that provide a unique combination of properties that are able to be resistant to UV, ozone, and other chemicals listed by the Navy. If you look at the bottom left corner of the slide, you'll notice the materials that we've chosen is able to be injection molded, which is amenable to large-scale manufacturing. But alone without any surface treatment, the injection mold cushion is able to withstand a vast amount of UV and ozone. If you look at the picture to the far right, when combined with surface treatment, our clamp cushion is able to repel hydraulic fluids and fuels that is currently used by the Navy, which is helping protect it even further, reducing the maintenance and the cost overall. On the next slide, we'll provide a brief summary as to where we are currently at on the project and expectations set for delivery of an alternative single-loop clamp for the Navy. On this slide, we're going to go ahead and discuss the project schedule and the milestones that LynnTech is expected to accomplish. So currently LynnTech is in the phase 2 base period, and at this stage of the project we're completing prototype development, which is currently leading into validation certification testing. By the end of the base period, we're expecting to have completed all aspects of the project, which also includes developing manufacturing plans, processes, and preliminary cost analysis associated with making and delivery of the single-loop clamp cushion. Over the course of the Phase 2 option period, LynnTech will have more end-user interaction and evaluation of the final prototype. Now, it was identified in Phase 1 that the current specification sheet applied to clamps and clamp cushion materials are likely outdated and need to be updated with current industry standards and capabilities. In addition, it is recognized that specification sheets also need to be modified to make them more relevant to the new clamp cushion material developed in this effort and to make them more relevant to modern operational environments, concerns, and demands of today. Therefore, LynnTech is also expected during the Phase 2 option period to provide input towards this specification sheet based on LynnTech's techno expertise and know-how in the various aspects of the clamp cushion composition, cushion performance, and relevant testing methods and conditions. The end user will provide input based on their experience and expertise on the field use of clamp cushions, along with their unique and highly valuable perspective on clamp validation and certification testing that better mimic field conditions under which clamp failure is currently observed. As we progress towards the post-Phase 2 option period, we will continue to demonstrate prototype refinement and continue to do validation through operational testing, all in collaboration with the Navy's technical team. And it is also expected that LynnTech will be able to actively contribute to getting a qualified product list for the new clamps, accelerating the process of transition towards DoD procurement. On this slide, we're going to go ahead and highlight some of the key features, advantages, and benefits that LynnTech's alternative clamp cushion material offers. Now, the clamp cushion material chosen for this effort has shown to exhibit superior performance and possesses many attributes that can drive transition and product to commercialization. Shown in this fab table is what we have identified for the hydraulic single loop clamp cushion. And for example, is the material is readily available in bulk. It has the benefit of being UV and ozone resistant, durable, flexible, and shows slow permeability to vapors. Now, the utilization of cost material to act as a surface protectant also provides the necessary resistance to fuel and hydraulic fluid that the clamp cushion materials will come into contact with. Another advantage is the ability to prepare the clamp cushion in various colors in order to be in compliance with industry color schemes. And finally, the favorable economic factor that is expected using the alternative hydraulic clamp cushion materials developed by LynnTech. So it's low cost, its availability of materials, the utilization of being manufactured using existing processes and infrastructure is quite important as we work on transition from product to come into fruition. This makes the clamp cushion ability to have large commercial potential, and most importantly has the potential for applicability across a wide range of industries. On the next slide, we're going to discuss a little bit of how to transition from where we're at now to the fleet. So after prototype development is completed and the hydraulic single loop clamp has been procured by the Navy, the clamp is expected to be provided to the Naval Air Systems Command and transition to probable fleets such as the Hornet, Super Hornet, and the Growler. And from their application of the single loop clamp can be transitioned to the other DoD programs and contractors. Lastly, the single loop clamp can extend for use on non-DoD markets, for example, commercial and civilian aviation. As mentioned earlier, LynnTech has a proven track record of matching technologies with the corresponding appropriate business models towards successful commercialization. Therefore, at this time, we have identified two business models and will be partnering with specific entities that are likely to push our hydraulic line clamp cushion. Therefore, LynnTech is looking to either fabricate the clamp cushion material and providing it to the clamp assembler, or fabricate the entire clamp and provide it to NAV sub and OEM prime contractors. In terms of partnerships, we're seeking relationships with entities such as Boeing, Lockheed Martin, Sikorsky, companies that manufacture or maintain civilian, commercial, or military aircrafts or helicopters, and companies that specifically purchase or provide MIL DTL 85052 clamps. At this time, I would like to take the opportunity to thank you for listening to our brief presentation. You can contact our VP of Business and Development, Brian Hennings, or myself if you have any questions or if you happen to have any ideas for potential application of our technology. Again, thank you for your time and have a great day.